Foundation models for embodied decision-making agents, part 23. This is going to be a short one, I think, because it's really just a comment that Levine made recently at a presentation. It's about the question of specific data versus autonomous data. Specific data is, let's say, what Tesla is collecting when they're collecting videos from driving data and then training their robot to drive. So that's specific driving data from humans. It's human driving, collected from humans that are driving. And the goal of the data generator, which is in this case the human driving, is actually to introduce as little randomness as possible, assuming that you're driving, like most people drive. Now, that that is the, let's contrast that to the other extreme, which is imagine a robot that is completely untrained and that just starts doing stuff, and then you have a sort of a goal layer, like a layer with which is trained. Let's say that's trained, so that's given the goal. And the goal would be, let's say, just drive from A to B. I'm not going to teach you anything about how to do that. You're going to have to figure that out all by yourself. Let's say you do this in simulation. So what would happen? Like that robot would obviously autonomously start driving and then reach the goal. Now, of course, we have to be very cognizant about the goal itself, because in simulation, the robot would maybe drive through people, drive through, into buildings. But it's conceivable that if it's fed enough data, it will actually even learn not to do that over time. Right? This is one of those things where we just need a lot of data and a lot of compute. Because it will figure out that the goal to reach A from B cannot be reached by constantly bumping into buildings. Now, we might give it a little bit more constraints in the goal policy, right? Do it at low cost, do it without killing somebody, or things like that. But that's the challenge, right? That's the challenge already right there. And when we go to the first version, which is the human driving, we have through inverse RL, if you will, we actually have a reward function, which is simply, well, that's what people do, right? We don't know what good driving means. We don't know what it means to get from A to B in an optimal way. There's no textbook version of that action that tells us, well, this is the good way to do this. But we can watch people do it and potentially learn how to do it from those people. So that's that's the space in which model designers live. And Levine mentioned that going from specific data, where again, with specific data, we are solving the actual task. Okay, if we take a robot, let's say that's baking a cake, we learn how to bake a cake, but we're also understanding what is the best way to bake a cake, like the reward function. Should we first start with the dough, or should we do this, or should we do that? Like those kinds of things are also being answered when we look at specific data. Let's say we watch a baker bake a cake live or on YouTube, right? So this inverse RL that gives us a reward function is incredibly important. And My question to Sergey is really like if we want to go down the route of autonomous data, what's how do we what's the conversation about the goal layer or the goal function or the reward function or how do we do that? Like, is that becoming obviously that's becoming more crucial? And maybe let me step back now. Why do we even try to have autonomous data, right? Why not just learn how to do things from humans? Let's remind ourselves, recent episode, Abhinav Gupta from CMU, who actually talks about this a lot in his work and recently went out of stealth mode with his company. So this is a real thing. Billions of dollars are already being put into companies that are trying to solve that problem. So this is not just an academic problem. Why are we trying to get why are we trying to get autonomous data? Why are we trying to get robots to figure stuff out autonomously? Well, because they can probably do a better job and come up with, move 37s, I think. Is it move 37, move 33? I think one of the moves that AlphaGo Zero chose that was surprising. Like, we could have the AI actually figure out stuff that we humans don't even understand. So we could have agents that can learn how to learn and then figure stuff out that we don't even know. And I think in principle that is absolutely possible because these agents, they can iterate a lot more than we can. And if we can do it in sim, then they can also fail a lot more than we can. So just from that perspective, it's conceivable that they will come up with much more interesting solutions than the ones we have because we're constrained, right? Human driving is incredibly constrained by, but let's say just by our embodiment, right? We get tired. We need to go to the bathroom. Robots don't need to do that. They might choose different routes, different ways to get from A to B, just based on the fact that they don't have those constraints. There are other constraints, of course. They have constraints about, let's say, the speed with which they drive. It's a lot faster than we think. Actually, that's not even. I'm not even sure about that. But anyway, like we could have a whole. I think a PhD could be written in theoretical comp sci about the different types of constraints between robots and between humans. So that's certainly, it would not be possible to talk about this in this particular episode. So let's leave that aside. But just let's put the point out. I think this is the beauty about, like, almost every time I come across a presentation by Sergey Levine, I end up with very interesting questions and really interesting also paths of research. And to me, that is always the sign of a good researcher when you have, when it opens your door, when it opens your mind and opens doors to more interesting work, more interesting, questions and problems that could be solved. This is Karl Popper right there, right? We solve problems, create new problems, and we just keep going. So let's get back to the presentation now. Again, he's talking about the potential for autonomous data. And I guess what I want to sort of discuss here is the pros and cons of autonomous data, or what that actually means in terms of foundation models for robotics, right? I think we've seen with FSD that specific training, data that is specific, again, in terms of giving us, giving us one way of doing things, one trajectory in action space that works. And with human driving, I think that's obviously a path that we must take, at least for now, because there are human rules to be followed. There's other humans that expect driving robots to follow human rules, at least for now. Again, this might change, but we can't have too many accidents because also regulatory and psychological pressures could actually kill the project. So we have to be very cognizant of that. The same applies to humanoid robots. The definition of humanoid robots actually is robots that act in human spaces. That's really what the definition is. So it's not about them looking like humans or something like that. It's about them acting within human spaces. That's what's really important. And I think that's where the value creation is, because a lot of work in factory type settings happens in spaces where humans are operating. And what we want is robots to be able to help them there, to do work for them in a way that they don't hurt anybody and get the job done. And that can be, at least for now, probably the best course of action is to have them learn from specific data. But that doesn't mean that we should stay there. You know, Abhinav Gupta's approach and company are all about trying to have more innovation in learning and learn from autonomous data. We've seen also work at Stanford, in particular, Shuren Song was talking about the robot that just constantly, collects data about certain tasks on its own, and then we can take that and what that means, though. Okay, this is where I'm going with this. The challenge with autonomous data is the reward function, right? How do you tell the robot what's good and what's not good? You want it to be autonomous, that's fine, but you need to be able to guide the machine towards good behavior. And that becomes the challenge. And in my opinion, that's a whole research area to be explored, all right? What is actually good behavior? I mean, we have that same problem, of course, even with humans, right? We have that's what religion is there for, right? The ethics, morals, the law. I mean, all these things root in the same question. Well, what is good behavior? Like, we have this autonomous agent called human, and they obviously act in certain ways, and we don't even know exactly what it means to act as a good human. What is a good human? And we have philosophy, existentialism, and all kinds of things written about this particular problem. Maybe you just have to act and then see what happens. Camus and the whole existentialist movement. There is, Philippa Foot, which is, the trolley problem, which is you can't act as a good human, period. There is no such thing as good acting. You're always going to be exposed to a trolley problem sooner or later. So get over it, and then maybe find a way to define good action in a way that you can actually hurt people. There is absolutists, hardcore, religious types of people. They say, look, I don't care what good acting is. It's the scripture. Follow the scripture, and that's it. And in my opinion, that is the source for most wars in humanity, because you just justify everything with the scripture, and then you can obviously change the scripture or the interpretation of the scripture according to what you think is the right thing to do, and so on and so forth. I mean, I don't want to go too deep into this conversation, but the question of what is a good act is as relevant for humans as it is for robots. And I think in Sergey's presentation, these questions are not discussed too much. He's just talking about sort of the transition from specific data to autonomous data. And I wanted to use this episode just as an opportunity to point this out. I think we need to think about what is a good act, and if we want to go down the trajectory of having more autonomous data in training, so having robots figure out stuff on their own, then we need to start developing solutions for goal space. What is the goal? How do we define a goal? And how can goals be learned? Because that goes towards the Robinson Crusoe robot, right? Once a robot has a good sense, like take a human, like How do we know what our goals are? It's a really important question. And a lot of people actually suffer from that problem. You know, there's no, we don't have purpose, we don't have this, we don't have that. Now, I can tell you one thing. If you get dropped on an autonomous island somewhere, excuse me, on a deserted island, you will not have a problem with purpose. You will have a very clear understanding of what it takes to survive, and you will do things to survive. So the question then comes, well, is that the goal then? Is it survival? So let's take a hypothetical example. Let's take a robot, let's take a self-driving car in simulation, and you put survival as its North Star. And then you let the thing drive, you know, do its thing. Is it conceivable that that car actually will learn how to drive pretty well because it knows it won't survive in a human setting if it kills people, right? So survival actually is not, in my opinion, that's the path to go. In my opinion, that's the path to go, because once you have an overarching theme like that, you don't have to specifically define, well, you have to be nice to people in order not to be put aside. You have to be nice to other robots because they might kill you if you're not nice to them. And there's this opportunity here, in my opinion, to have a conversation about an overarching goal, which, again, in my opinion, could start with the conversation of survival. Of course, we have to discuss what that actually means. How long is survival? Also, you know, you could just, let's say, kill all other robots to get more resources. You have to be cognizant about that. I mean, those are questions that we humans also have, right? Take a lot of conflicts where survival is always in front of everybody's thinking. But then you have to ask yourself, well, okay, if I kill everybody in order to survive, then maybe I become a target myself. So to summarize this conversation about autonomous data versus specific data is a very interesting one. It opens up opportunities, but it also begets the question of what is the goal. If we have autonomous robots that train autonomously, they need to have a certain understanding of what the goal is. And there's a potential that the goal could be survival, something along those lines. So then the robot, same like a human, has a North Star that it can follow and learn. Thank you.